Welcome to Neutralizing COVID, the monoclonal antibody story, the podcast where we unpack the science, strategy, and real world impact of monoclonal antibodies in the fight against COVID 19. I'm your host, Dr. Shikha Agrawal. Today, we are focusing on a group that's often at the center of conversations around monoclonal antibody treatment immunocompromised individuals. These are people who may not mount a strong response to vaccines and rely more heavily on treatments like monoclonal antibodies for protection. But how well are these therapies working for them? Are there still gaps in protection? Let's navigate through the episode. Monoclonal antibodies for immunocompromised patients in context of protection gap. Welcoming our nanomedicine researcher, Dr. Aiswarya Chaudhuri, for another episode. Great to have you here, Dr. Aiswarya.
Thanks, Dr. Shikha. Excited to be back in the conversation.
To begin, could you explain why individuals with compromised immune systems are considered at higher risk for severe outcomes from COVID 19?
Immunocompromised individuals have a weakened or a suppressed immune systems due to the conditions like organ transplants, cancer treatments, autoimmune diseases, or genetic disorders. Now, this makes it harder for their bodies to respond to infections. And it also means they often don't produce a strong immune response after vaccination. As a result, they can remain vulnerable to severe illness from viruses like SARS-CoV-2, even if they have been vaccinated.
And that's where monoclonal antibodies come in.
Exactly. Monoclonal antibodies are the lab-made proteins that mimic the immune system's ability to fight off the harmful pathogens. Now, for the immunocompromised patients, these antibodies can produce or provide passive immunity, meaning the protection doesn't rely on the person's own immune system to generate a response. Instead, they are given ready-made antibodies that immediately begin neutralizing the virus.
Well, how effective have these treatments been for immunocompromised groups?
Early on, monoclonal antibodies played a critical role in both treatment and prevention. For patients unable to make their own antibodies after vaccination, long-acting antibodies offered a form of protective shield. Now, some therapies showed strong effectiveness in reducing hospitalization and severe outcome, especially when given early. Others were also used prophylactically, that is given before exposure to help prevent infection. But there have been challenges too. As the virus evolved, some antibody therapies lost effectiveness against the new variants, which reduced the options available.
That leads us to the issue of protection gaps. What are the key factors currently contributing to these gaps in protection for immunocompromised individuals?
There are a few reasons. One is viral evolution. The SARS-CoV-2 continues to mutate, especially in the spike protein. That is the main target for the monoclonal antibodies. Now, when these changes affect the regions antibodies bind to, the antibodies may no longer neutralize the virus effectively. That's lead to the withdrawal or reduced use of several earlier monoclonal antibody therapies. Another factor is access. Even when effective monoclonal antibodies are available, not all immunocompromised patients can get them quickly, whether due to supply, regulatory decisions, or cost. And lastly, timing matters. Many monoclonal antibodies are most effective when given early in the course of infection or before exposure. Delays can reduce their impact.
Really insightful. Are there any antibody therapies still in use that offer protection today?
Yes, but the landscape is narrower than before. As of now, only a few monoclonal antibodies remain in development or under evaluation for current variants. The key is to develop broadly neutralizing antibodies. One, that target the parts of the virus that don't change much across the variants. Some newer monoclonal antibodies in trials are showing promise against the recent trends. And the researchers are combining multiple antibodies in a single treatment. what we call an antibody cocktail to reduce the chances of the escape.
Well, you mentioned long-acting antibodies earlier. How do those differ from regular monoclonal?
Long-acting antibodies are engineered to remain in the body for months rather than weeks. This is particularly useful for the pre-exposure prophylaxis, where the high-risk individuals can receive an injection that provides protection over an extended period. Even they can't generate protective antibodies themselves. Modification to the Fc region of the antibody help increase its half-life by improving recycling in the body. Now, some long-acting monoclonal antibodies were used for the COVID-19 pre-exposure prophylaxis. But again, their usefulness have been affected by viral mutations.
It sounds like there's still a real need for next-generation monoclonal antibodies.
Absolutely. For immunocompromised people, vaccines alone may not be enough. So monoclonal antibodies remain an essential tool, but they need to be updated or adapted to match the current variants. We're also seeing work on pan-Sarbeco virus antibodies, which aim to neutralize not just the current SARS-CoV-2 variants, but related viruses as well. That could help offer a more durable protection in the future.
What's the bottom line when it comes to monoclonal antibodies and immunocompromised individuals?
The key point is that the monoclonal antibodies can offer life-saving protection, especially for those who don't respond to vaccines. But as the virus changes, we need to keep evolving the antibodies too and ensure they are available to those who need them most. Uh, this group continues to face a unique risk, and protecting them requires targeted tools that adapt along with the virus.
Thanks, Dr. Aishwarya. This was really insightful discussion and a reminder that COVID-19 isn't over for everyone, especially those who remain vulnerable.
Thank you, Dr. Shikha. Glad to be the part of the conversation.
That's it for this episode of Neutralizing COVID, the monoclonal antibody story. To our listeners, thanks for being part of the conversation. Don't forget to follow and share this episode if it sparked your curiosity. Until next time, take care and keep exploring science.